Thank you so much. I'm very happy to be here. I hope everything can hear and see everything what is required. The last row always has to do the thumbs up. Thank you so much. So it's a pleasure and an honor at the same time to be here in this very interesting group, Diginomics. I'm very looking forward to the discussions we might have about the research or the insights I'm going to present here. I think, as with many topics in the logistics domain or operations domain, as you introduced, Mike, thank you so much, are very interdisciplinary. So it means that there are many connections, there are many collaborations. We already are collaborating here with Arndt and Vera Hagemann regarding psychological research and aspects in these topics. So it's quite interesting to see all these links and interrelations, and we are very open, and I'm also introducing or welcoming you to answer questions, to have some comments during the talk, because I think it can be quite a small group. It can be a very good dialogue here. So we might or will have, this is the abstract you might see in the file when you later get the slides for your post hoc analysis, we call it in research. So the agenda is typically 5 points. We will have a short introduction. We will have a research concept which is aligned with this Industry 5.0. We will have 3 dedicated and detailed research examples from ongoing papers and research which are connected to this overall topic we are discussing today. Let's call it the human factor or Industry 5.0. And then the, let's say, innovative part of my talk will be to get more into discussion also with the researchers here in Bremen. Is the question of customer communications or customer integration, because I think that's a field which is very much overlooked at the moment. This topic of Industry 5.0 is very much in the operations, logistics domain, production domain, obviously, like Industry 5.0. But I think this has very many implications also for market, customer communications and integration, and maybe also for general compliance and finance and ESG, for example, issues. So I think this could be a very interesting research inspiration maybe for some of you to think about what the future will hold in research regarding this topic of Industry 5.0. And then I will provide some ideas for discussion, and I'm very happy and we go into discussion. So the background is the motivation here that in many contexts, in any industry, in many company context, what we see is what we call a sort of hybridization. So many tasks and many processes in companies, service or manufacturing, physical manufacturing, doesn't matter, are becoming more and more merged between a human part of the activity, so human people are doing something, and a sort of technology part, digital part, extended reality, mixed reality. So we have so many technologies coming up, and this impacts or this implies that also the standard value creating processes in companies are changing. They're changing very fast. So you see some examples here from manufacturing where we have what we call a cobot now. It's not anymore a robot. A cobot is a collaborative robot, so he's interacting with human workers. So in the past, also regarding safety regulations, for example, it was always very demanded or very clearly regulated also from the law that actually robots have to act. You might remember some pictures from automobile production where we have these big robot machines and they are in a separate area. So usually the robot work was completely separate from the human work. And this is now coming together, as you see in this picture here. And cobots mean that actually the cobot is doing something and he might give the task or the product to the human being. So they are really interacting, they're really in the same process. And this implies for many things, for psychological, for safety issues, for productive efficiency issues, a different set of design, a different set of conceptualization, because it's not separate anymore. It's really integrated. So we have, and you will see some examples, we have cobots following humans, we have cobots collaborating, like providing things to human operators. So this is very much changing in many different contexts, in manufacturing, in warehousing, in logistics, and also service settings. You all know that we talk also about robots, cobots supporting, for example, people in healthcare. So there will be many contexts also in service settings where we have these hybridization, these collaborative work. And the second example, and that's actually from the healthcare sector, also regarding training. It's very interesting that extended reality, like also the metaverse, which is a big topic coming up, that we have interesting collaborations between human operators and these mixed reality or extended reality settings. And this is not only true for training, this is also true for the standardized operations in typical systems. And what is very interesting to me in my research is the third point we see here, that in the most context, at least for the warehouse and the logistics setting, we can a little bit prove that empirically. But I think also for many different settings, like in healthcare and the other settings, it's very interesting that we in general assume that the hybrid scenario is actually superior. So it's more efficient, more effective, because we have this example I like very much from chess here. You might assume, and in many contexts, when we think back to Industry 4.0 discussions, especially engineers maybe, I'm not against engineers, but it's always an interesting discussion. In many contexts, people assume that a fully automated scenario is the best one, and this is not true. So if you fully automate something, if you have only machines, only technology, only robots, usually it's not the most efficient or most effective scenario. But instead, the hybrid scenario, so the combination of technology and human operators, is the best one to go for companies, for the economy, for the supply chains. And just this small example to explain, if you look into chess, and everybody knows that in the area of chess, computers have been competing, beating humans for a long time. I think it was 96 with Kasparov, if I remember correctly, the first time a computer was beating a human player. And since then, it was clear that computers themselves, or software programs, are playing better chess than a single human. So therefore, you can easily compare the best human today. I think it's Magnus Carlsen, who is it? The chess champion, world champion at the moment. He has an ELO rating, and this is quite interesting in chess because you have the exact number of the playing strength of one player, which is this ELO number. And the current world champion has a number of 2,861. So we can very much or very exactly determine what is the playing power or qualification of a human player. We know that computers, and they are also, I learned that, tournaments where computers play against computers, and computer software is reaching a maximum ELO number of 3,546. So you can easily see it's higher, it's better than the best human player. But on the other hand, we have hybrid teams. There are also tournaments. There are some championships, something where you have software and human teams playing together as one team against other teams of software and humans. And these teams actually achieve ELO numbers between 3,500 and 800. So this means they are even more very quantifiable. They are even more better playing chess than only a human or only a computer. And this is a typical example I like to quote here or to show that in many contexts, we actually find this situation like in chess, that the combination of human operators and technology is the best you can have, the best scenario. The question is how to achieve this scenario and actually how to design these systems, because the collaboration or the mix, this hybridization of human operators and technology is not an easy thing. You cannot just put any person with a computer and say, okay, you're a team playing chess now. It takes some, let's say, training, some thinking about how to do that. And exactly that is what is happening with the new concept, what is called Industry 5.0. It comes or it originates from the European Commission already 1.5 years ago, December 21. They issued a white paper saying we need a new sort of paradigm because we have all experienced the trend or development of Industry 4.0. This was the idea that technology, that machines, computers, artificial intelligence can take over specific activities. So the basic idea, and we can discuss this also if you're interested later, the basic idea of Industry 4.0, I would say, or 4.0 is that machines or entities, technology, taking their own decisions by being independent, by having their own information, so sensory equipment, being connected to each other. For many, this is the core element of Industry 4.0, that actually machines, computers, containers, products, pallets are talking to each other. So there is a automated communication via the internet usually, where everything can connect or communicate with everything else. So your fitness watch can talk to your smartphone, to your computer, to your car, to your fridge, whatever. So that's 4.0. And the basic idea is that these items also take decisions. So they are in a way independent. We don't need any more human decision makers. But there was a sort of missing or a sort of gap, and that was the basis for this concept by the European Commission, saying in this process, looking at what technology can do, that they are independent, they have autonomous decision possibilities. Actually, the human operator was a little bit forgotten or left out, let's say. It was not so much in the center of attention anymore. And exactly that's in contrast to what I was saying before, that actually what we need to be very efficient, very superior is the hybrid system. So we need human operators as well as we need technology and these machines and artificial intelligence, for example. So the idea, to say it in one sentence, behind this new catchphrase Industry 5.0 is that we want to have an integrated system where not only the technology, but also the collaboration of the human actors, operators, are integrated in a comprehensive design. So therefore, what they call this is human-centered systems. So any new technology, any capability, for example, of computers, of machines to communicate, to take decisions, should be connected or should be oriented towards what the human operators are actually doing and deciding. So there should be a very productive, a very efficient collaboration of all this new technology. So we use it. It's not that 5.0 is not using technology. It means we use all the technology which we have in the future with ChatGPT, all these technologies, but we will use them in collaboration centered towards the human operator. So we are not leaving the human workers out. We're actually putting these again into the center, or at least in a very prominent position in all these processes, in all these ideas. So what the European Commission is saying, we want to have human-centered systems. So all these technologies, all these processes should be oriented, or let's say in relation to the human workers, the human operators. And this implies, and that's quite an interesting thing, because I think also for our research in the future, this has to be a little bit more detailed, what this actually means. Because the connection is that, at least from the idea in the white paper, is that with having human-centered or human-centric systems, we also might or will have the ability to increase or to support more resilient processes and supply chains. And at the same time, they should also be more sustainable. So these two objectives, I think, where everybody in the company or in any decision position would say, yes, we should be more resilient, we should be more sustainable. So that's not a question if we are doing this or not. Sure, we want to do this. But the question is, and that's from my perspective, something also for future research, we have to analyze, we have to make sure that the idea which is placed here in the white paper, that human-centered systems and processes are actually contributing, are supporting resilience and sustainability. So it's not, I would say it's not a given, it's not an automatism, but it's something as an opportunity or as a possibility we can achieve. And the question is, how can we do that? And that's, from my perspective, a very interesting research goal. The European Commission in the white paper has further issued some ideas that actually there are specific benefits connected to these 5.0 concept. So this means the companies should be more efficient, as I was explaining with the hybrid scenario. It should improve safety, well-being. It should improve the workers remaining in control. It should improve the possibility for human workers to train, to adapt, to evolve even. That's quite interesting for the HR and people-oriented management science areas. Interesting concept that actually this human-centered is not a static idea, but it's a dynamic idea, that also the people, the workers you see here in the middle, are able to evolve, to develop, to grow, whatever you can call that. So that's quite interesting from my perception, and to bring it a little bit more down into the practical situation, you see this interesting machine up there. And this is exactly as we have seen in the first slide, what we call a cobot at the moment. And that's the latest technology from Still in Hamburg. They are now trying to sell to their customers in the warehouse. So in the past, and that's maybe a little bit hidden, in the past, you have these old machines in red. In an old industrial truck, which is driving through a warehouse, usually the operator has to step on the truck and has to steer the truck. So that's quite old technology we have for the last 50 or more years. So this means the truck, the red one, is not driving without the human operator on it. So it's only human control. There is no independence, there's no new technology. But the new technology here in this orange, which is called IGO-Neo, new for Neo, many names with Neo now. This IGO-Neo has the ability to travel independently. So this means this machine is actually following any order picker who is going through the warehouse and picking these products here for the supermarkets. That's from Rewe, so you know the Rewe supermarkets. And this is the warehouse where all these products are coming from. And the task is, as you see here in the back of the truck, some order pickers, like human operators, have to pick all the products, put it on a truck, and then it's transported to the truck going to the supermarket. This is happening in the warehouse. And the idea is, and we actually started to measure that together with Rewe, and we have measured around about 17% improvement of speed performance in this process, alone by the fact that this orange machine, the new industrial truck, is following independently the human operator. So what they are saving, what is the improvement in the process is, in the old truck, the human operator has to step on the truck and then drive the truck, and then steps back, steps down, goes to the shelf, takes the product, puts it on the truck, and goes back on the truck. And this part going on the truck is not needed anymore with the orange one. So the orange one is what they call coupled. It's a very interesting process. I'm trying it myself. So you're actually registering with this orange machine. You have a small infrared sensor at your here at the belt. And then the machine is actually recognizing you. The interesting or maybe even funny part is the infrared thing is only a basic communication, but actually this orange machine has a sort of radar system. And the radar system recognizes actually your bone structure. So when you're actually connecting to this machine, the machine is actually recognizing you as a person, individual one, regarding your bone structure, your legs. So it's very interesting because in this warehouse, there are around about 200 people running around selecting these products. So it's a very complex situation. And the engineers for this machine had to make sure that the truck is not following any other person. So it's not a simple or trivial task. It's very demanding engineering-wise to make sure also in safety issues that this orange truck is actually, when it's following a person, really only following the right person. So it's a very elaborate technology, I would say. And it's very interesting. If you have the chance to experience it, I would recommend doing that because it's really like a dog or something. So you walk across the shelf, take the products, and the machine is just coming behind. It's just following you. You can show, okay, it should be 20 or 30 centimeters behind you. And it's actually just following behind. So what is completely cut out of the process, that's the efficiency gain, is stepping on the truck, steering the truck, that's just out of the process. So the human operator is only concentrating on picking the products, putting it on this truck, and then they as a team go through the warehouse. So it's very interesting, you could say even small scale technology, but I would say it's already showing what the future is holding because we have completely new questions now. I will outline that in my talk a little bit because there is a sort of interaction, there's a sort of team, there's a sort of, so the interesting, let's say, anecdote here is we tested this truck with Rewe. They now ordered next 5 of them for the warehouse in Heidelberg. And the first 2 people using this first machine, they actually had the fear that they would lose this yellow machine because from the 200 operators, the question is who gets the new truck? And there are 4 more to come. And actually what they did, they put stickers on this machine because they wanted to keep the machine. They said, this is my machine, which never happened to the old trucks, the red ones, you can imagine, because that was just any red truck, it doesn't matter. But the new one, and that's very interesting also from a psychological point of view for work motivation, it means that actually there's a sort of connection, there's a sort of interaction which has not been there before. So people are starting to bond or to work together as a team with these cobots. And you can imagine there was a talk before where somebody was suggesting that maybe they even bring dog food or something because they see it as their dog following them. So it's really becoming, and maybe some people now call them names or something, I don't know. So it's very interesting. You might refer to many of these films and movies where you see the artificial intelligence and robots and they give them names and they have very special relationships or interactions, whatever. But this is starting to happen in a typical warehouse. It's not anymore just in a movie or any other situation. It's really happening for a standard order picker, 200 of them in a standard logistics warehouse for retail. So that's what I wanted to show as a very operational example, what is happening there. And now we will look into 3 different use cases or research cases. We are proceeding now with 3 papers in these cases, because we think that actually what we have seen as a white paper from the European Commission needs a lot more detail, because these general, let's say, wordings, human-centric, resilient, sustainable, these are quite high level. So it's very general. Everybody will agree, okay, we want to be more resilient, we want to be, you know. So we think, and I would like to introduce 3 case studies or 3 papers for these additional points you see here in green. We think that this is connected to very specific challenges or tasks we have to look at in research, but also for the companies in the operations practice in order to actually deal with this challenge of Industry 5.0. Because just to say it's human-centric is not, you know, operational. It's not, you cannot implement it, you cannot do it. But we think that there are 3 important issues, which is safety, which is collaboration between these cobots or technology and humans, and which is learning. So I will try to give a little bit more detail by providing 3 cases where we already did some empirical research, and you can see also what is the difference maybe to what we did in the past. Because at another talk in this situation about Industry 5.0, somebody was asking, okay, already in the past, we have done research regarding, for example, human-technology interaction. So how do humans interact with computers, with screens, with robots, with, I don't know, with your watches? That's correct. So we already have a sort of knowledge, a sort of existing research regarding what is happening if one person is actually working together or communicating with a screen, with a computer, with the software. But what is changing, and that's what I want to show in these 3 cases, what is changing now are 2 things. One, we have a much broader perspective. So in the past, we were always looking at a specific interaction of one person with one screen or with one machine. So we were asking where to put the levers, where to put specific buttons or icons in order to make it very efficient, right? The interaction between a human and technology. But now we are looking at a very broad aspect because we are, for example, and that's one of the cases you will see, we are looking at a whole workday or whole working week. And how do humans actually, in a long-term perspective, operate together with these cobots or with any other technology? So it's a much more long-term or broader perspective. And at the same time, that's the second aspect, which is changing in our research and also in management, maybe later on. Second aspect is we are going much more in detail because we now have possibilities, and that's also what we're doing here together with the team of Vera Hagemann, for example. We have much more technologies available, starting from your Fitbit watches to, or the smartwatches, to heart rate sensors, to EEG sensors we're using. We have much more technology available to actually measure, to analyze with detailed data what human operators are actually experiencing, how they are feeling, how their performance and how their capabilities are developing. And if you combine these 2 aspects, long-term analysis for 1 day, for 1 week, or even longer, together with detailed data about heart rate, EEG, whatever, cortisol, we are testing a lot of things. Then you can imagine that the picture we're getting is much more detailed than just analyzing one single collaboration or interaction between one human being and a screen or a machine. Right? So that's what we will see in these three cases, that we are very much looking into details, and we are also looking at a longer time frame. The first example is this example together here with the team of the Hagemann in Bremen. At this department, we are looking at the question how the workload or the stress situation for drivers, truck drivers and train drivers is actually or can be measured, can be determined. And it's very interesting, as I said, because we have a very broad set of data. Just one example is the EEG, so the brain waves. This is actually what Antje is doing. Thank you for doing that. So I think this picture is from you, actually. Thank you. So in this project, we're looking at a very broad data set, starting from EEG to other things like, for example, heart rate and so on. And what is the idea behind it? You see here an example of a truck driver. He's wearing this technology, this mobile equipment, getting the brain waves. Because then in the end, what we can do, we can show from a real work-life setting. So it's the real truck driver in the real driving situation, driving around Bremen or any other place, and a normal working day, and we can analyze how the development during the whole working day is actually happening. In the past, we only had these analyses or data for lab situations. So we could do an EEG only in a stationary setting. Now we can do it in a mobile setting. So this means we can really see in this terms of brain waves or heart rate or, for example, cortisol tests, what is happening during the whole working shift. So from 6, 7 in the morning to 17, 18 in the afternoon. And this is very interesting because this also connects what is the safety issue, what I was talking about here in this topic. This connects to the question, what is dynamically happening? So is the driver getting tired? Is he losing attention? Is he actually influenced by specific situations, like, for example, the weather, the time of day, the traffic situation, or any other situation? So we can have real life data regarding these interactions, because that's something we cannot simulate, we cannot test or analyze in a lab setting. So the real interaction with, for example, fog or with rain or with night light or whatever, this we cannot test really well in lab situations. So what we can do now is we can actually gather all this data, starting from the EEG, the brain waves, to heart rate, to other data, and we are collecting this together. And the idea is, we see here some examples. This was the analysis of Arndt, actually, about the alpha spindles, they are called. So this means it's a sort of indicator for attention. So the question is, when a brain actually tries to concentrate or to focus the attention of the driver, obviously in this case, then you see these specific signatures of the EEG, and then you can actually measure them. That's the work we did in the project here. And you can see that during the working day, these specific signatures of focusing, the brain is trying to focus on a specific task, on driving, these are actually rising. So during the day, you can interpret it the other way around. It means it's harder to be focused. It's harder to stay at the same level of tension. So therefore, the brain has more work to do in order to stay concentrated. That's exactly what we would actually expect. It's also interesting to see that it's not a straight line, which is also quite obvious or clear, because there are different influencing factors. So that's all what we know from our working day. When do you eat something for lunch? When do you have specific interactions maybe with other people? So these very small, let's say, normal work situations are actually to be seen in these data sets. So we can recognize what an individual and maybe also a group, a collection of drivers are doing. And when there are specific situations, they are influenced in their attention, in their focus, in their capabilities to actually be a safe driver, if you want to say like that. So obviously the sort of data we are getting here, this is new. We don't know of any other publication or any other research doing this in this way. So this real life data gathering provides us with the opportunity to have completely new connections of such data with issues like safety. So what is the attention level of the drivers? What is influencing them, and so on? And the latest step in this research is that we're actually using artificial intelligence to analyze all this data, because we have really a huge data set. It's millions and millions of data points for every second. We get the heart rate, we get the EEG lines, everything. And we have also, and that's interesting as a combination, we also have the speed of the truck, we have the weather situation, we have the traffic situation for every situation, for every second. And this means we have really a big data, a huge data set. And now we are applying the idea, the technology that actually machine learning, so artificial intelligence, is trying to analyze these connections. So actually what a single human being cannot do anymore, but the machine learning, the neural networks behind that are helping us to identify connections. And just as a short insight from this research project, you see these two pictures here. And what they are representing is the result of a machine learning algorithm showing us in which specific connections we have identified specific situations connecting to stress, which is measured by heart rate. So if the heart rate is rising, the machine or the algorithm, the machine learning, is actually recognizing that this is connected to specific situations or specific conditions. Not just that there are two explanation options. So one is the driver has to work. That's also what we can measure. So he's not driving, he's actually loading or unloading or whatever. But in this case, we identified or isolated that actually is driving. And then the question is, what is the external or what is the specific factor influencing or leading to these increased stress or heart rate levels? And what you can see here, it's very hard to interpret it because the AI is some sort of black box. But what is happening here is we see in the upper picture that there is a certain area, which are the red data dots you can see. In these two areas of the red clusters, we have a connection of a specific condition with increased heart rates or stress. And if we erase the weather data, the picture changes to this one. So that's the change in these two pictures. And what you can see is we have not anymore two red clusters where these stress levels are indicated or detected, but we have only one cluster left here in the middle. And this means, and that's the next step we are doing now with the artificial intelligence in this research, this means that actually the weather plays an important role in these identification of stressing situations for the driver, which is very much obvious. We can all relate to this when we drive a car and you have fog or you have heavy rain or something. It's definitely more stressful. It's definitely more demanding to drive, even more if you have a truck, not only a private car. So therefore, we can relate to that, but actually it's a new level of research. It has never done this way before, because we are actually collecting empirical data on these driving situations and connecting or analyzing them with artificial intelligence. Any questions, discussions about the truck drivers? So in the end, what I want to say is, in the end, we will use this, and this is paid by the German work department on the federal level in Berlin. In the end, the idea is to use this model or this data in order to identify basic influencing factors for stress, for the work conditions of drivers, in order to improve the work situation of drivers. Maybe even a sort of application you can have on your smartwatch telling you, okay, at this point, it might be a little bit stressful, please do something. Or we all know that from the cars, they are now starting to tell us when you should take a coffee break. This is just a very easy version of that one. We want to do this in a more elaborate version to understand exactly or more in detail how the truck drivers are actually working and how their stress is influenced, how they are actually receiving stress and how we can do something about it. Yes? Yeah, thank you for the question. It's very important because actually it's all in all the research fields or cases I'm showing now. The general idea that we have human-centric process and system obviously also implies that we have to look into the human situation. And this means, exactly as you're saying, we are talking about very personal data, even medical data. So about your body performance. So the next case. Yeah. So I would have 4 short key points about this question. The first one is we are having the full, let's say, spectrum, the full instrumentarium of anonymity and data security in research. So we have an ethical board. We have full anonymity of all these drivers doing that. So no data can be drilled down or connected to individual persons. So this is all data aggregated for more than 30, 40, 50 drivers. So that's the first answer. So what we can do in terms of data sovereignty, anonymity, we are doing ethical board. The second thing is we still have some people in these test series, for example, who are rejecting it. And I expect that we had a similar discussion with experts in the field of healthcare, digital healthcare, for example. There will always be a sort of group, and we have to accept this. We have to deal with it. We have to find ways to deal with it. But we have to accept that there will always be some people, smaller group maybe, let's see, who will not go this way, who will not comply, who will not cooperate, which is okay. So we don't have to punish them or to do anything. We have to accept it. And in this case, it was, I think, with 2-3 drivers who actually rejected to not do the measurements because they said, it's too personal. I don't want to give my data. So I think we have to accept it. We have to deal with it. The third answer is that actually, as soon as we explained to these persons that in the end, the idea is to improve their work conditions. So you have, in the theory, in research, we call this process sense making. So we have to explain what is the objective, what is the idea behind it. And if they understand, really understand that in the end, when this research is successful and we have some sort of application or some sort of whatever measurement we can do, in the end, measures, then their work situation is improving. So it's not, for any other, it's not for the company. In these cases, the company doesn't get the data. It's only with us as researchers. And if they understand, and we also included the unions and all these councils representing the workers. And if you do this communication, this integration of the workers and explain to them, convince them, if you want to say so, that it's to their best, it's actually for their advantage, it's to improve their work situations. Then we see that most of these people, of these drivers in this case, are actually accepting it and saying, yes, we want to work with that. Because yesterday we had a workshop discussing with these drivers, and as soon as they understand, we are actually asking them in order to understand their situation or to improve their situation. It's not for us as researchers, it's for them. And if they understand it, that's good. And the fourth issue is we have a sort of aggregate level, which is completely distinct or completely above the individual level. So for example, what we see here, that the weather has an influence, or we have collected some interviews with these drivers telling us that for them, the most stress also comes from the customer side, not from the truck or the driving or the weather, but also from the customers. So this means that, for example, we can provide some sort of, let's say, checklist or advice for the companies to deal with the customers, which are providing the goods and getting the goods. So therefore, it's a sort of, I would say, abstract or general level where we can derive knowledge, where we can derive improvements, which have nothing to do with the individual level. So it's about how to organize the supply chain, how to organize the acceptance time windows at the industry companies and the retail companies. So this is something which only addresses, let's say, the general level of supply chain and transportation, not the individual. And this could be, even from my perspective, the most valuable one, because we are discussing about changing settings, changing frameworks, not only the individual situation. So that's the fourth answer I will give to the question. Thank you. Okay, the second case is also quite interesting from my perspective, because as we said here, maybe quite bold, we are trying to open up a new research stream. The idea is actually coming from a special issue in the journal, the Production Operations Management Journal, and we have a paper there in the second revision. The idea is we connect areas which have not been connected before. One area is the traditional operations management. So we're looking at process times in a warehouse, similar setting. But the other area is diversity management. So an area which is traditionally rooted in strategic or HR management. So the question is, we have diversity among the workforce, we have different people. And the interesting question is, how can we actually combine with data, with an empirical approach, how can we combine diversity issues with operations management issues? And we picked a very interesting, I would say, very interesting example, because what we're looking at is we are connecting a very typical, I've explained the picture here, a typical warehouse setting, so similar to what I explained with this orange truck. people are picking the products in the river warehouse again. We have the same data from river, and the people are picking these products, and we have a large diversity. I was myself surprised about that. So we have a large diversity between the people, these 200 order pickers in the warehouse. And we found that, for example, roughly a quarter of them, 30% something, are actually have a cultural background, which is no evaluation, it's just a fact. So linguistic diversity is a fact. It's there in a global perspective. And the interesting thing is we have writing and reading directions which are different. So we are used to read and write from left to right. And there are other cultures and languages where you're used to read and write from right to left. What I learned in this research, there's even in the Asian area, there's even a culture where you read and write from top to down. So it's actually what the literature or the research tells us about this. We have three major systems of language, writing and reading, which is left to right, right to left, and top down. What we are looking at here is we have in this warehouse actually around about 30-something people having the background, the cultural background, having learned writing and reading from right to left. So we produced two groups, one group with the people reading and writing from right to left, and one group, a control group, with reading and writing from left to right from their cultural background. So we're not talking about any other issues. It's just about this very hard fact, we could call it. What is your basic, what you learned in school, your basic writing and reading direction? And what we combined now is we checked. The interesting thing is in the aisle, in the warehouse with these shelves, you're actually traveling in the shelf in order to pick these products. And you're traveling typically, in this case, in a what we call a Z shape. So regarding or depending on the products they have to pick, that's the color scheme you see, that the pickers have to traverse or have to go through the aisle. And the interesting point is now we can measure, we have a very large data set with more than 3 million picks. We can now measure and compare and calculate, does it make a difference for the people, the 30 people reading from right to left, to the people reading and writing from left to right, if they are actually in the aisle, traveling from left to right or from right to left or straight. That's the three options we have in the aisle, in the shelf. So that's exactly what we can calculate, what we can show here. And the interesting thing is we can find empirically a significant connection. So it shows, and that's the next page here, it shows that actually the people, and that's the combination you see here, the people who have a right to left reading direction, so that's the background from the cultural area where you have this right to left reading direction, they are obviously slower. So this is the picking time, the typical performance we are looking at in operations management. And they are very much slower. We can find a significant difference when they are actually walking in the aisle from the left to the right side. So against their learned and, let's say, cognitively embedded system for their writing. And the interesting thing, which was a little bit surprising me, is that for the other people with the left to right, like we are, or people in Germany would learn in school, with left to right reading direction, it's a similar situation. So for them, exactly the other side, going in the aisle from right to left, is making them slower. So it means that actually, to put it very bluntly, your brain is in a way characterized or already rooted or directed in this typical writing direction. So therefore, your performance in being in this shelf and picking the products is actually influenced. And we can measure it, we can significantly show that these differences play a role. So that's now a very interesting insight, because it means that organizing these processes in the warehouse might be influenced and might be designable, so we can use the knowledge in order to improve the process, which has never done before. Because when we presented this, we discussed with the DHL representative, and I asked this DHL person, what would you think your warehouse in Germany usually has, for example, the walking direction and the writing direction left to right? But what is the warehouse in Saudi Arabia or any other country where you have the opposite writing direction? Do you actually change your writing direction in the warehouse and your walking direction in the warehouse? So this has many implications for operations management, but also for our research. because we can show that taking these, and that's just an example for diversity. This is a very small example about the writing direction. You could take many other examples. What is diversity for you actually? Starting from gender to whatever. And the question is, can we establish such an empirical link between diversity characteristics and hard facts in operations management, like this picking time? So it's a very hard fact regarding how long does it take to pick the products, right? To get them out of the warehouse. So this is quite interesting because we provide a first indication that actually this connection is not only, let's say, two separate fields. Somebody does diversity management, somebody does logistics operations management, but it makes sense to combine it, to look at it from a combined view. And this is exactly what I wanted to show as a collaborative view between technology or operations and humans, this human-centered factor, because it might improve our logistics or operations if we look into these, let's say, soft issues of diversity management. In the past, this was not done before because in engineering and logistics, we already had this mathematical issues and we assumed that all the human operators, these 200 order pickers, are actually the same. There was no distinction. There was no idea that there are differences between these people. And this is not true in reality, right? So this is the interesting thing. I just want to give you a short glimpse or a short insight that we have a new research trend, I would call. We have increasingly special issues as here that actually the question is, how can we use empirical, so reality data, empirics on the right-hand side, and interact or combine this with what we have done in the past. This was only analytics driven. So we have a lot of optimization models. We have a lot of mathematical, let's say, models and methodologies to optimize routes, to optimize warehouse locations, whatever. But we have not so much these combinations or this interaction. And this case I was showing you with the writing direction is a very good example for this. We are observing in the reality that there are differences between people. And the question is, how do these differences actually influence our decision parameters? So how we organize the routing, how we organize the shelves, how we organize all these processes in the warehouse. In the past, this was completely independent. So it was just done, warehouse optimization from an engineering perspective was just done in an analytics view. So we were looking at what is the optimal route, the shortest path. That was the sort of research we were doing the last 50 years. Nobody was actually checking if the real life situation, like how the human operators do that, is connected or is matching with what we have done in the analytics part. And this is a new trend, and I would say the writing system direction is a good example, but there might be others. So maybe an inspiration also for research if we want to. There are many other indicators or characteristics of humans which are not yet looked into, but they will definitely have an impact on these performance of these process issues. Right? So I think that's a very interesting connection, or you could call it a circle, interaction between real life data, what we see, what is happening in practice, and the typical mathematical modeling where we find decisions about optimal routes, optimal locations in a warehouse or whatever. So I think that's very worthwhile to think about this in the future, because it's also sort of what we would call increasing the impact, for a moment, increasing the impact of this research we're doing. Because in the past, when we only calculate, let's say, the mathematical optimization, and there was no real connection to the real life situation, it was very often, and I had these examples from Ray, where they told us, oh, there was somebody from any university coming and saying, I have a better routing algorithm. And then they tested it in practice and recognized it doesn't work. Because there are so many parameters, so many of this diversity, heterogeneity, which is influencing how trucks are driving, how people are moving in the warehouse. And this was not at all embedded or included in the algorithm. It was just a mathematical optimization. So therefore, this, let's say, interdependence, or let's say talking to each other between the real life situation and the mathematical optimization would also definitely increase the real life impact we might have with our research. Because then the models or the suggestions we could give for companies will definitely have a more value, more worth than at the moment. It's a very interesting point, and I might go back, if you allow, to this. There's an established theory, it's Thomas and Ellie, 96, and they have defined, I found it very interesting, I didn't know it before this paper, this research. They have already in 96 defined that there are 3 levels of diversity. So it's really only diversity research only. And they were saying, and it was very interesting for me, at least, or for the team in this case, to connect these three levels to our example, because then you can see what would be the value also for diversity management. So they said the first level of diversity management is for companies or any organization, can also be university for sure. For any organization, the first objective, the first level of diversity management should be what they call the fairness paradigm, to make sure that no person feels discriminated against. So I think we can understand, we can relate to that very easily. And when I read that one, it was very clear to me that in this case of the writing direction, it is obvious that maybe unconsciously, maybe not on the conscious level, but definitely unconsciously, people having a different writing direction might feel discriminated against, because most of the processes, especially in the warehouse and logistics, I'm totally sure, are organized or related to the left to right writing direction. So I think at this level, we can agree that this is very obvious. For the companies, it makes sense that they look into this, they relate to these people having this specific differentiation. Where this comes from, so where the heterogeneity comes from, the diversity in this language, is not our question. So that's maybe a separate thing, but we assume that we have it. And as I said, we were surprised that there is already a considerable diversity in the warehouse, for example. The second level is that companies should, or organizations should, ensure that actually the access and legitimate access or paradigm of the persons should be upheld by the company. What this means, it sounds very artificial or maybe theoretical, maybe. This means, for example, many companies are using the diversity characteristics of employees, of persons, of people, for a specific competitive advantage towards the customer. A typical example, especially in Germany, I'm not sure about other countries, but a typical example is that companies, for example, use country flags to show what is the language competence of specific people. So when you go to a bank counter or any other counter and you see, okay, there is not only the German flag, but also the English, US, and maybe Turkish, whatever, this indicates that this person at this counter has specific language qualification. Also, characteristics of diversity. And the idea on the second level is that it's not only to make sure that there is fairness and these people don't feel discriminated against, but actually the organization can use these differences, these diversities, as a sort of advantage towards the market, towards the customers, like with the language. The question in our case would be, if we talk about this writing system direction, the question would be, is it, and that's a very interesting question also for other contexts, for any organization, is it legitimate? Is it accepted also by the employees, by the people, that now we would, knowing this, we would start to reorganize the warehouse process in order to use this difference to the advantage of the organization? Right? So it would be an interesting, also, let's say, moral or ethical question, because like with these language things, is it okay, is it accepted that a company and organization is actually using these differences rooted in diversity and heterogeneity in order to improve or to have a competitive advantage in terms of picking process time, in terms of customer communications, right? So this is an interesting question. I think you can discuss for any context. Is it okay? Is it fair? Is it accepted for an organization to use these differences to have an advantage, right? So I think that's a good example. If the company now changes the routing direction, and then they have to explain to the people, why are we doing this? And if they say, okay, we are doing this because part of the group is reading and writing from right to left, is it okay if we change it that way, right? So I think that's an interesting diversity issue. And the third, and that's, I think, the most discussion prone area. The third area is, can we use these diversity issues in order for the whole organization to learn and to get better? So this would indicate, just as a rough start of a discussion, this would indicate that actually we would share these research results with the group of order pickers, all the 200 order pickers and their team leaders. And then we would try to start a sort of, initiate a sort of discussion, learning process, so that they would, and that's a very long-term, maybe learning objective for the organization, that they would understand that there's some sort of diversity in the group, which they might not have looked into or discussed before about this writing direction. And the best, let's say the best objective in this third level would be if they understand that there are even more or other diversity characteristics, not only the writing direction, and they themselves would go further and think about how to use these differences, these diversity for their own benefit, for the company's benefit. So I think that's a very high goal or high level to achieve, but still it's worthwhile if diversity is not just done in terms of to have a diversity management, but actually for the whole organization, the whole team to develop, to learn, to use this as a first step to improve in any further way. So I think if you think about in detail about these three levels, you can understand from my perspective that the connection to diversity management is very active, very detailed, and it makes sense to think about it more in detail. And at least from us as logistics operations researchers, I think it's very valuable to go further in this direction. Thank you. Yes, it's definitely, let's say, a background or framing, I agree. But what I was saying in the beginning, I would argue that we're actually looking several levels deeper, because the traditional assumption is, okay, we have a Japanese sort of management style or Asian, European, American, whatever. This is not looking at the individual level. This is looking at cultural groups or larger groups, higher level, right? So what we're doing now is we're looking at individual persons with their different diversities or differences. This can also go back and say, okay, the language direction or writing direction definitely has a background in the cultural framing or cultural setting, right? So therefore there is a connection, but I would argue that we are on a much more detailed level, on the individual level now with this data than before when we only discussed about what is different between European and Japanese management styles or operations, right? So there is a connection, but it's
that specifically what was on person language style and stuff, and then you have the performance.
We can connect to that very much. Yeah, I would fully agree.
Because diversity could imply something, management could imply an outcome.
Yeah,
probably.
Yeah,
So
I fully agree. I just
it is more like an input.
Yeah, so I fully agree that there's a strong connection and we should explore this further. And we are on a more detailed level, so therefore it might also provide new insights back to the cultural level discussion. Right? Thank you. It's not yet finished. If I already finished or reached the objective, it's okay. I would definitely say, so the first question is very easy. Yes, we control there are only right-hand persons in the sample. So that doesn't play a role. Second answer is I'm completely agree that we should think about all these issues. We have just started this empirical research. So we have not looked, and actually it was interesting to us that in this special issue, we were limited to only 4,000 words. So the normal 8,000 word length was cut down because maybe somebody in the editorial board thought, okay, diversity is not such a big issue. We only get what I'm just joking, but it's really an issue. We only got 4,000 words for this paper. So we just restricted on reporting these results. And then that was not a joke. As I said here, we think that this could open up a complete new research stream. So I think the implications from the cultural management to what actually we could do about these differences in diversity combined with operations management. So I think the questions which we derive for management, for hiring, for organization of shifts, for organization of team planning, whatever, until the question you're mentioning, should a team or let's say the workforce for this warehouse be combined 50-50? Or would it be even more advantageous for a company to say, okay, this warehouse is 100% left to right riders and this warehouse is 100% right to left riders? Because then we can optimize according to the specific situations of these two groups. And if you think about, for example, Railway has 22 warehouses in Germany. So they're roughly about 50-80 kilometers apart. It wouldn't be a hard work to actually separate them between two different warehouses. At least we can think about it, right? So I fully agree that we should explore this further, and I fully agree that this would be very valuable for operations management, logistics management, and maybe also general diversity. Thank you. No. It's always good to have a discussion. No problem. Yeah, we can provide this feel very quickly because one warehouse with Raver is doing on average 180,000 picks per day. So this means 180,000 times 1.3 seconds saving. We have not all, so this is on. We have to somebody use a calculator maybe online. But I would roughly guess that we are talking by about 200 people in this warehouse. I think we are roughly talking about 1 to 2 persons we would not need anymore. So this is really significant. Very easy question. Thank you for the fast question. So now I'm presenting the third case. And the third case, if you remember the 3 green buttons in the first concept draft was about learning. And the interesting thing, and maybe this is the most, let's say, humorous part of these 3 cases, the interesting thing here was we used the same data set and we're actually now combining the 2 areas. You have seen the truck drivers in the first case, you have seen the order pickers in the warehouse. And now we are combining this because exactly between this situation, when they pick the products from the shelves and the trucks driving to the supermarkets, the real supermarkets, somebody has to actually put these products on the truck. And the interesting part is that putting these roll cages, we call it, so these finished goods on the truck, for us, maybe as not operational people, seems very simple. You just put the things on the truck. But actually, in real life, it's not that simple. And maybe you can see this here. There's a video. Because it's not the same roll cage. It's not the same truck in every case. So what is happening there with all these gates, the people are putting the products on the trucks. And the challenging or the demanding situation is that all these different roll cages you see here have different shapes, have different weights, have different sizes. And the same is true, which we can't see behind the gates. The trucks also are different sizes. So when you look on the street, you have a very large truck, you have a medium-sized truck, you have a smaller truck, you have a refrigerated truck, so with cooled items, you have a non-refrigerated truck. So there are many different trucks, we call them platforms, to transport the goods. And the interesting thing now is the combinations of all these different products for cooled goods, for non-cooled goods, and so on, is a little bit like playing Tetris, because you have to put round about between 20 and 30 of these items on one truck. And the question is, and there is no support, there is no technological solution, it's just the experience and the work of these human operators putting the wares, the goods on the trucks. And the interesting thing is, we now tested in this paper, does the experience of the human operators play a role? Because you can imagine if you play Tetris once, at the beginning, it might be very hard to do this Tetris game if you ever played it. And then you gain experience. You understand how you have to shift and do these things in order to make them fit very nicely in this sequence. And that's exactly what they are doing. And the interesting thing to us was, to make it very short in the end, the interesting thing to us was that it's not only the what we call volume experience. So that's the total experience you have, how many of these goods you actually put on a truck in your career, in your lifetime. Obviously, this plays a role. So the longer you are in the business, the better you are, that's for sure. But the interesting thing is also that the variety experience, that's the different products you have handled. And the platform experience, that's how many different trucks you have seen. So we can measure that the, let's say, drill down experience, not only how many goods you have actually put on the truck, but how many different of these roll cages you have seen during that, how many you have handled, and how many different trucks or platforms you have seen doing that is at the same time playing also a significant role. Again, the question of Mike is the numbers are quite small, but they are significant. And if you think about this is not 180,000, but roughly 18,000 times a day that they put goods on the truck. So if you multiply very small gains or efficiency improvements with these high numbers, volumes in the warehouse, you still achieve a quite significant economic advantage. So that's what we can show. What we call the Tetris experience is the combined experience between the products, different products, sizes, shapes, whatever, and different trucks. So we can see that these specified or specific experiences are playing a very important role. This is interestingly connected to a very high-level discussion we have, for example, in a journal like Management Science, where the discussion is there a difference between what we call volume experience? So this is just, we all know, economies of scale. So the number of things you have handled and then is increasing, then you're getting faster, you're getting more efficient. And actually the other position or the other idea is, no, it's not just the volume experience, it's actually the specific setting experience. There are, for example, some interesting papers in management science looking at the question, if you transfer human, what is it called, surgeon for heart transplantation, so very standardized procedure. If you transfer a surgeon from one hospital to another, how does the performance drop? Because the number of procedures this surgeon has done is staying the same, but the setting is changing. So you can differentiate between what is the general volume experience. So he had done so many procedures in his life, but he has done no procedures in the new hospital. What is it changing? Is he getting slower, or what is changing in his performance? So that's super interesting. It's a very high level discussion we have now in management science and operations regarding this learning and this experience issue. And we are connecting to this development in a very interesting fashion. And we see some, let's say, interesting things here. So we are opening up what we call the black box of learning. So the general learning curve we all have learned in our studies is not just the general learning curve. It depends on the settings. It depends on what I showed with this Tetris game, with different boxes and different trucks. So there are many more factors influencing this general learning curve we all know about. And it's very interesting for research, I think, to look into this specific experience. And in the end, why is it relevant for Industry 4.0? In the end, it's also a question of individual situations of people, because they have different experiences. And we are also looking at the question, what can we do about it? We could develop training sessions. We could develop dedicated training modules or courses, because when we know what is exactly the influencing factor for these performance changes with experience, we actually could tailor or could dedicate specific training sessions to this experience or to this question. So now I want to introduce my discussion question for today, the last 17 minutes. The interesting thing from my perspective is that this, as I said, is a trend or research development in the operations management domain. But I think that these questions we have seen about human-centered systems, Industry 5.0, are not only restricted to the logistics and operations domain. I would argue, thank you, I would argue that this also has a very important aspect in customer communications or customer integration. Because, and you might remember this picture, because for me at least it was very eye-opening. I'm not sure if you remember the incident. I might have two sentences. It was around about 6 weeks ago that there was a strike of truck drivers near Frankfurt. That's the what we call a resting place or stop at the motorway in Grafenwöhr, at the motorway number 5 in Germany. And it was very high in the media because there were, you see the trucks in the back, the blue trucks there. There were around about 30 trucks, and they were striking because they didn't get any money from the logistics company in Poland. So it was a very complex European setting. And the interesting thing was that actually this logistics company in Poland did send a private security company. This is the truck you see here, this black one. This is a private Polish security company. And they did send this truck to Germany, on the motorway in Germany, in order to convince the truck drivers to drive again. So you can imagine it was a little bit forcing issue. And then the German police, what you see here, had to come and actually to separate these security people, these security guards, from the truck drivers, because they were starting to push and, I don't know, fight, whatever you call that. So it was really a very, I would say, dire situation. And it was really in the media because it showed how the working conditions are in these European trucking business. Yeah, we have many companies. I'm not pushing or not blaming any specific company or country, but we have a situation where the question of transparency, of quality control, how the working conditions are actually on the streets, on the road, is not transparent to any person like us as consumers or any company. So in this case, it was also, when you want to look it up in the internet, it was also quite interesting because then some journalists started to check for which companies these trucks, these products are driving. And these are all the names of the German industry. It was Volkswagen, it was IKEA, it was all the companies who have goods on these trucks. And then the companies started to issue statements to say, oh, we didn't know anything about this. We just gave an order to DHL or Schenker, I don't know. And that's a typical situation we have in this business and transportation. So the big company like DHL is ordering the transportation from a smaller company, from a smaller company, from a smaller company. So in the end, the big company like IKEA, Volkswagen, they don't know what is happening with these drivers when they are driving. But I think this has to change. If we really think about this Industry 5.0 situation, that we want to have human-centered, we have social sustainability, we have human-oriented situations, then we need, I think, more transparency. We need more customer involvement. So the question is, and therefore I put these examples here, the question is, also for research, I think, very interesting, marketing, communication, how do we actually make this work situation transparent for the industry companies, but also for us as consumers? So we have many different systems, like, for example, these certificates. That's the forest stewardship certificate. So you know that the products with this label are actually produced in a very sustainable manner for wood. Or you have the so-called Nutri-Score. I'm not sure if you would agree with the objectives and the systematics of this Nutri-Score, but definitely it's a sort of, we also have these energy labels with A, B, C, B, A+, whatever. So we have different systems where we try to communicate actually a sort of performance or situation in the production, in the supply chain. And the question is, would it be interesting for research and also for practice, for retail, to actually start some sort of this communication system, this structuring system, in order to make these work situations of production workers, of transportation workers, more transparent to the companies and also to the consumers. So if you think about, we might have, and therefore I call it the cyber responsibility system, just as in Jetson. So it makes sense that we use all the technology, so we can check on our smartphones, we can use a lot of information. Why shouldn't we make it feasible that actually consumers and also industry companies like B2B business are better informed and use this information for their supply decisions, for their purchasing decisions, right? So I think it's a very interesting area to think about in research, because as I said before, in the past, this was very intransparent. And if you take this idea of Industry 5.0 very seriously, I think we need in research and in practice, we need much more communication, transparency between what is happening on the roads in the factories and what the customers and the industry companies actually know about it. So therefore, it's an interesting development. We'll jump this and come to the last slide here in order to have a short discussion in the end. I think the interesting point about this Industry 5.0 is that it has so many connections to many different disciplines, or you could say management science areas. I just put some examples here to give you a first idea, a first starting point for our discussion maybe. So for example, what we have seen in many of these operations contexts is how people perceive their self-perceived situation with the new technologies. So we, for example, also had a paper on riders. When you look at the Lieferando or any other platform where you order food, you have these riders which are organized by a platform. This is also a very modern style of logistics with a digital device. And the interesting thing is the work performance of these riders is very highly depending on what they think, what they perceive in terms of autonomy and control in their work situation. And this is very interesting because in the end, it doesn't depend, and that's very, if you look into this business, it's quite interesting because in Germany with Lieferando, for example, the people are fully Social Security employed. In many other countries in Europe, the people are freelancers. So in the end, their, let's say, work motivation and their performance does actually not depend on this, what traditionally we would assume. We would assume that people who are fully employed in a Social Security job, like we are at university, are more motivated, or vice versa, maybe the freelancers. But actually we found in this research, which we gave the paper here, that this is not the crucial point. The crucial point is how the platform is organizing the allocation of the orders and how the individual riders are perceiving that. So do they perceive that they are controlled, that the platform is actually dictating them and saying you have to take this order and you're controlled and you're checked? I did an interview personally with the rider, And then I recognized after exactly 20 seconds, they get a sort of ringing tone if they are standing still. That's a very interesting sort of control because the GPS and the platform, the algorithm is checking if they are standing still more than 20 seconds. We did the interview, so therefore he was standing still. And then they get a sort of signal saying, what are you doing? This is not a red light. This is more than 20 seconds. Why are you standing still? You should be driving. So that's just a short glimpse what is happening there as a sort of control. And these issues, how actually the platform is interacting with these people, regardless if they are employed workers or if they are freelancers, is very much influencing their performance. So I think this is a very interesting thing about psychology, so work and HR psychology. So it's quite interesting to look into these issues in a sort of digital logistics and operations settings. The second field is also interesting if you think about computer science. That's a C here on the left-hand side. So in the future, we'll not only talk about human-human and human technology, that's what we are talking today mostly, but also we'll talk about technology-technology interaction. So for example, DB Schenker has issued now the first software where software bots are actually negotiating transportation contracts with other software bots. So in this sense, there is no human involved. There will be only two pieces of software for two companies, and they're going to negotiate the price of a container going from Bremen to New York. So there's no human person involved. So in the future, it will be very interesting also for our research to look into this question, how technology interaction is happening, how bots and whatever entities, artificial intelligence, are actually collaborating, working with each other. What is interesting for the finance part, that's the third issue here, is from my perspective, what we also learned from Rewe, that traditionally we all assume that there's a new technology. You have seen this orange truck, and this is replacing the old technology. But actually, it's not happening like from one day to the next. But there was this example I told you from Rewe. They are planning now to replace the old red trucks by these new orange trucks, but it will take 3 years because this is quite expensive. It's not like only for 10 euros you get this new orange truck. So they have an investment plan. So therefore, it's a finance issue, I would say. And the question is, when does it, in which timeline, does it make sense to have it in 3 years or maybe only in 1 year or in 5 years? So this transition or changeover period is very relevant for these new technologies because we are talking about very high values. We also talk about performance improvements for sure. So I would say the typical investment case calculation gets a very important or new, let's say, value for these contexts, because we have to analyze in a comprehensive way what these transitions, what these investments actually mean for companies. This implies also, and that's very interesting for the, let's say, engineering or the employment part of it, we have to deal with a period, in this case of Rewe, of 3 years, where the old technology and the new technology is working in parallel in the same warehouse. So there are two different types of these industrial trucks, and all of the 200 workers have to deal with it. They have to deal with the 10 new ones and the 90 old ones, or vice versa in the end. So it's quite an interesting interaction question, how you organize this parallel operations between old and new technologies. Also, what we learned from Rewe in these cases is that diversity or heterogeneity between people, between humans, is not only connected to their specific characteristics like lighting directions, but also we recognize that there is some sort of informal hierarchy. So the people from HR, that's the H here, may be familiar with that. So in a typical human setting where you have teams, you have people working together, there are also these informal hierarchies. So you have opinion leaders, you have people which influence the other people, you have people saying, okay, we should do that or shouldn't do that. And we recognize that for the question of technology acceptance, so if these new orange trucks are really accepted by the team, by the people, it's not only relevant that management and maybe the official team leaders are saying, yes, this is a good thing, or the union leaders, but actually there were informal opinion leaders. You didn't see them. You cannot, there's no sign for them. But for example, in the first case, we analyzed, it was an older guy, like about 50, who had the most experience. So most people in these teams were looking at this one person. And if this one person says, yes, this is good, we should use the new technology, they are following. If this older person would say, oh no, this is maybe not so good, it's not secure or whatever, then most of the people would reject the technology. So it's very interesting to look at these human resource or these team issues. So therefore, it's quite interesting. And the last part is the engineering part. It's an I for the German engineering, sorry, because the E was taken. But the engineering part is about the safety issues, and that's my closing remark. The people, the engineers from Still for this orange truck, they told us that actually the development time for this new truck was around about 4 years. And then they told us, okay, after 2 years, the truck was fulfilling, this orange cobot was fulfilling all the legal requirements. So they could have started to sell the truck to go to the market already 2 years ago. But they decided not to do that. That was a high-level management decision by Still in Hamburg. And they said, we're not going to the market. We're taking 2 more years in order to establish additional safety features. Because, and that's a very intelligent thinking, and I think it's a role model for many of these things happening in the future with technology. They said, we understand if there's one major accident where one of these machines might injure or even kill a person, then we can scrap all the program. We will not sell any of these machines for the next 10 years. So they said, okay, it makes sense as a business case, as a strategic management decision. It makes sense to invest 2 more years of development to make this machine not only abiding to the law regulations regarding safety, to make sure, okay, every regulation, every law is fulfilled, but make it even more safe, even super safe, because you have to avoid in any way that there is a major injury, there's a major accident. So this was for me also quite eye-opening, because you have to understand that this is not just the safety issue. If you talk about human technology interaction, is really at the center, it's really at the core. And if you make any mistake there, it might ruin your whole business case, your whole product line, whatever you have here as a supplier. So this is quite interesting, and I'm looking forward for the discussion with you together here. And thank you for being here. I'm looking forward to the discussion. Thank you.